Yes. Angle O1 is the angle at the center. So angle at the center theorem will apply. So in this case, it means that angle O1 is equals to twice angle N1. The reason being, we say, remember in Euclidean geometry, you have to give the reasons why you say angle O1 is twice angle N1, because angle O1 is angle at the center. Angle at the center is twice angle at the circumference. So it makes sense that why I'm saying angle O1 is twice angle N1. And another thing that students overlook or learners overlook, when you apply this theorem, angle at the center is twice angle at the circumference, you need to be very careful. You have to know that the angle at the center and the angle at the circumference must be subtended by the same chord. If you look at the angle O1 here, being the angle at the center, what subtend angle O1? What forms angle O1 is the line from K and the line from M. When these two lines meet, they meet here at the center. Okay, I can see your hand, Sentwe. When these two lines meet, they meet here at the center. So we say angle O1 is subtended by K and M. So angle O1 is subtended by KM because if you look at angle O1, the lines that form angle O1, this line and this line, I saw your hand, and this line. This line comes from K and this line comes from M. So we say angle O1 is subtended by KM. So we say angle at the center and angle at the circumference must be subtended by the same chord. If you look at angle N1, what subtend angle N1? This line comes from K again. Line from K, and this other line comes from M. So even angle N1 is subtended by KM. So we say angle O1 is twice angle N1. Angle at the center, O1 being at the center, is twice angle at the circumference, N1. Circumference just means at the end of the second. Let me respond to your hand, Sentwe. You can just unmute your speaker. I want to hear that question if there is a question.
Well, say can tendency there's something I'm not sure of it. Lawana kamo angle O, but it's in O1. Let's just
let's just say the other O because it's not specified. This side, this side, this side.
Yeah. And is 2 times the angle L. Is it applicable?
It's 100% correct, actually. It's 100%. It's correct. It's correct. Yeah, we will explain it. It's 100% correct. We'll look at it some other time, but you are surely right. This angle is twice angle L. I agree with you.
Okay.
So Erikikwe Lebogang, are you happy with the fact that angle O1 is twice angle N1? Do you understand why we say angle O1 is twice angle N1?
Yes.
Okay, that's great. Angle at the center is twice angle at the circumference. Just give me only seconds. I just want to see 10 seconds. What's happening here? Can you please? This thing can be very slow. It's fine. Let's just carry on. Okay, angle O1 is twice angle N1 because O1 is the angle at the center. Now let's look at other applications that we can make, other theorems that we can go for. Remember, I'm not answering the question yet. I'm just trying to understand the diagram. I'm trying to interpret the information. And when I interpret the information, I realize again, or let me just read what they are saying. They say in the diagram, O is the center of a circle, KLMN, and KO and OM are joined. Chord KN is produced to S, angle K2 is 55, and N2 is 100. Okay, everything that they are saying, they have shown it on the diagram. That angle K2 here is 55, and angle N2 here is 100. So let's continue with our interpretation of the information. Ooh, this guy did not tell us that K, L, M, N is a cyclic quad. They normally inform us that KLMN is a cyclic quad, but we know it's a cyclic quad. Why? Because it's a quadrilateral where all the vertex are at the circumference of a circle. Go ka lebella di corner ka moka tša this quadrilateral. Quadrilateral has got 4 sides. Side 1, 2, 3, 4. This shape that I've drawn with a green color, it's a quadrilateral. Now, when all the vertex are at the end of the circle, like this, we say it's a cyclic quad. Therefore, we know that K, L, M, N is a cyclic quad. Is a cyclic quadrilateral. It's a cyclic quadrilateral. It means that we are going to apply the theorems of a cyclic quad. We need to know the theorems of a cyclic quad. Let me engage with you guys. Lebogan, do you still remember theorem of a cyclic quad? Any theorem of a cyclic quad that you still remember, Lebogan? Any theorem of a cyclic quad? Lebogang, remember you have muted your speaker. Yes, any theorem of a cyclic quad that you remember?
I'm not sure, but the opposite angles are equal.
Oh, equal. You started very well. You said opposite angles. The way you ended, you messed up your theorem there. So any theorem of a cyclic quad, can you start with opposite angles? Opposite angles.
Opposite angles of a cyclic quad are supplementary. They add up to 180.
Good. Opposite angles of a cyclic quad, of a cyclic quadrilateral, are supplementary. They are not equal, Lebogang. The opposite angles of a cyclic quad are supplementary. When we say supplementary, we mean they add to 180. If you add opposite angles of a cyclic quad, you should get 180. So now we need to identify which angles are opposite. We have got angle L here, which is opposite to angle N1. So it simply means that angle L plus angle N1 should give us 180. What is the reason? Opposite angles of cyclic quad are supplementary. Opposite angles of a cyclic quad are supplementary. Angle L is opposite to N1, to angle N, and then angle K is opposite to M. K is opposite to M, L is opposite to N. Therefore, angle L and angle N1 should add up to 180. Even angle K, if we go to K, which is in this case is now going to be K1 plus K2 plus M1 plus M2 should give us 180. The theorem is still the same. Opposite angles of a cyclic quad are supplementary. Once you see a cyclic quad, you have to remember the theorems of a cyclic quad. One of the theorems states that the opposite angles of a cyclic quad are supplementary. Let me just draw my cyclic quad here. Let me just create my cyclic quad and create a quadrilateral. Remember, quadrilateral must have 4 sides. Okay, so let me say angle A, B, C, D. Let me say angle A, angle C, perhaps is 120. Can you guess what angle A will be sent to? If we were to say angle C is 120, what do you think angle A will be? How much you think will be angle A sent to if angle C is 120?
It will be 60.
It will be 60. Good.
60.
It will be good because we say A is opposite to C. And because ABCD is a cyclic quad, these angles, angle A, when you add it to angle C, must give you 180 because these are the opposite angles of a cyclic quad. Lebogang, if I were to put 30 here, what do you think will be angle D? Lebu?
150.
150, true. 150, true. Because opposite angles of a cyclic quad are supplementary. True. Impressive. Now we go. There is another theorem of a cyclic quad. It's not only about opposite angles of a cyclic quad. There is another theorem of a cyclic quad. And the other theorem states that exterior angle of a cyclic quad. Exterior angle of a cyclic quadrilateral equals to the opposite interior angle. When we say exterior, we simply mean the angle outside. So the angle outside the cyclic quadrilateral, the angle which is outside our cyclic quad, is equals to the opposite interior angle. If you look at angle N2 in this diagram here, this angle N2, you can tell is outside the cyclic quad. Remember, the cyclic quad is here. This is our cyclic quad. So when you look at angle N2, you see it's outside. So we call it the exterior angle of a cyclic quad. We say this exterior angle of a cyclic quad is equals to the opposite interior angle. Interior means the inside angle. So we have to ask, we already know that N is opposite to L. You have to identify angles that are opposite. In this case, N is opposite to L. Therefore, angle N2, which is the exterior angle of a cyclic quad, is equals to angle L. The reason Why angle N2 equals to angle L? We say the exterior angle of a cyclic quad equals to the opposite interior angle. The exterior angle of a cyclic quad equals to the opposite interior angle. So yakantle ibailekana lieling kamugare. So let me just create my cyclic quad alone. I mean again, somewhere here. Let me say this angle is 60. How much do you think is the value of X, Leborang, in this case? Leborang, how much you think will be the value of X, which is angle D? Oh, I forgot to write this ones. What do you think it will be?
60.
60. Why do you say X is 60? Can you give us the reason why you say angle X is 60?
Exterior angle of a cyclic quad equal to opposite interior angle.
Good, equals to opposite interior angle. Impressive. So in this case, we know that angle N2 equals to angle L. The exterior equals to the interior, the opposite interior. Okay, so we applied the theorem of a cyclic quad. We applied the theorem of a cyclic quad. I wonder if there is any other thing that we can apply here. We talked about the angle at the center. We talked about the exterior angle of a cyclic quad and the opposite interior angle. Guys, I was just interpreting the diagram, not answering the questions. I haven't even read the questions. I'm just interpreting the diagram. So let's now attempt to answer the question. They say determine with reason the size of the following L. You can now see how easy it will be to figure out the size of L, because you have already interpreted the diagram. What is the size of L, Sentwe? Sentwe, what do you think will be the size of L?
It will be 100 degrees.
It will be 100 degrees. They say you must also state the reason.
The exterior angle of a cyclic quad is equal to the opposite interior angle.
Exterior angle of a cyclic quad equals to opposite interior angle of a cyclic quad. True, I'm giving you these 2 marks. Angle O1. Angle O1. Yeah. Now you are making maths to be interesting. Thank you, examiner. Now you are doing it. What do you think will be angle O1, Leborang? What do you think will be angle O1? I love the examiner here. What do you think will be angle O1?
Angle O1 is equals to 160 degree.
Angle O1 is equals to 160 degree. Hey, very smart, clever girl. So I wonder how you got it. Can you inform us how you figure angle O1? That was impressive of you, Leborang. How do you get angle O1?
Angle L ke 100 degree. Then ra tseba gore angle ra tseba gore opposite sides of a cyclic quad supplementary.
Okay.
Then go ra re ge di le supplementary, then go ra gore ntshweng 180 minus 100 go shala 80 ka gore N1 le angle L they supplement.
Okay, nako kwele 80. That's impressive. Kwele 80. Remember, you have to show your workings in the exam room. Again, you have to show all these things. Angle N1 is 80, and then
angle O1 ke 160 because reason being angle at center is equals to 2 times angle at circumference.
True. That's correct. I'm going to answer it differently, but not necessarily differently, but the answers will be the same. Actually, you are right 100%. Is there anything you want to say about angle N1 centric? Angle N1 before I say something. Except it being opposite to angle L, is there any other way we can find angle N1? We know it's opposite to angle L. Yes, we know where angle N1 and L are supplementary, but is there any other way we can find the angle N1?
Yeah, it's 80 degrees angle on a straight line. Angles on a straight line. So
okay,
up to
angles,
100.
true, they add up to 180. So we are saying angle N1 plus angle N2 should give us 180. Angles on a straight line. Angles on a straight line, they add up to 180 degrees. So N2, if go kalabela angle N2, le angle N1, they are on the straight line, namely straight line, you can say KS, this line. So angle N1 and angle N2, they should add up to 180 degrees because these are the angles on the straight line. Lemogan, can you solve for X here? Can you figure out the value of angle X? How much you think is the value of angle X? Lemogan?
100.
100, good. Because all these angles, they are on a straight line. So they should add up to 180. When you add this angle, you should get 180. So N1, it's 80. Therefore, agree is going to be N1 plus 100 equals to 180. N1 equals to 80. If you take 180 minus 100, I think there is something wrong with my speaker. N1 is 80, and then we apply the theorem that says angle at the center is twice the one at the circumference. O1 is twice N1. O1 is twice 80. O1 it's 160. Levorang explained this one very well. That was very impressive. Indeed, angle O1 is 160. Then angle M1. How can we find angle M1? Let me just write 160 here on O1. How do we find angle M1, guys? Anyone? How do we find angle M1? Angle M1, 2 marks.
Yes, gape se ke tshwenye ke le gape.
Angle M1 It's not difficult. It's not difficult.
M1 is equal to 45. Quadrilateral LKOM. The sum of the angles of a quadrilateral, they add up to 360. Then
True.
then the add minus those angles.
Or you are
315. Then 350. But your minus na player for 45.
okay.
M1.
So you are looking or you are focusing on this quadrilateral. This quadrilateral. You are focusing on this quadrilateral. You are saying all angles in this quadrilateral, they should add up to 360. All angles in this quadrilateral should add up to 360. And you are right. So we say angle L plus K2 plus O1 plus M1. They should give us 360. I agree with you. What is the reason? The sum of angles of a quadrilateral. You will write the reason. In Euclidean geometry, you must always write the reason. So you will write the reason in the exam room why you are saying L plus K2 plus O1 plus M1 is 360. The reason being the sum of angles in a quadrilateral, they add up to 360. Angle L, we know it's 100. K2, we know it's 55. O1, it's 160. You have explained it better since I'm just showing the workings. M1 is equals to 360. You add like terms. Obviously, these are the like terms, 100 plus 55 plus 160. How much did you get when you add 100 with 55 and 160? 260, 40, 315. 315 plus M1 equals to 360. Therefore, M1 equals to 360 minus 315. Therefore, M1 equals to 45. You have explained it very well. That's you guys, you have performed so good on this question. That was very great. Easy 7 marks. Yep. And there is another question which seems very by looking at the structure, it seems very challenging, but we are going for it. Let's just try to attempt this question. Can you guys try to do the same thing that I was doing with the theorems? Even though I normally prefer complex stuff later. I normally like starting with basic. We will do this question. Remind me, we will finish with it. It will be the last question we look at, DBE 2017. I just want to pick the simple question and you guys, you go for it. Yeah, I can pick this one. This one is complex, but it contains a lot of theorems that I want to talk about. Yeah, let's go for this one. Don't answer the question. Can you guys see the theorems that are applicable here? This question, here you have to pay attention. This question is amazing because it possesses a lot of theorems. There are a lot of theorems here. I see many theorems. Can you guys try to interpret the diagram? Okay, let's do it together. Can we interpret the diagram together? Can we interpret the diagram together? You still remember how we interpret the diagram? Where you say angle T3 equals to B2, you give a reason. Actually, I want you guys to look at the theorems that are applicable. Look at the theorems that are applicable. Level la theorem tše leng gore sorry, level la theorem tše di leng gona tše re tlong go di berekiša godimo ga this diagram. Yeah, level la theorem tše di leng gona tše leng gore di tlo bereka godimo ga this diagram le tlo mpha tšona. You guys, just give me, I think, 2 minutes. I just want to fetch water. I need to drink water. I'm coming. Only 2 minutes. Just continue interpreting the diagram. When I come back, you should give me solutions.
Nna ke bona ntho ke bona angle T2 plus T3. I want. T2 plus T3 is equal to A2 plus A1. Like so.
Reason.
Okay. Reason angles from the same angles angles from the same point. The base angles are from the same point. Tangent. Ke tsebe gore ke le be ba botse jwang le bakale. A kgone go bega botse mare ke theorem ya re base angle ja isosceles triangle. Yeah. What do you want to angle down?
Like at the ball.
Thank you, one. Then the tan chord. Yeah. X. By one. X as B2. Tan chord on B2 again.
B2.
Lebogang karno lebogang ska no dumela ger ga go fora o mmoji ska no dumela lebogang because arra lo ke a gro ngwala in the exam o show wa kushisha nto o dumela. Oh sharp.
There tan chord X B2 ke X again. We want tan chord. Then Nampili carry A2 we want. A is equal to X, also equal to X, angles in the same segment.
Yaman. Send. Hey.
Yes.
No. Ngao tlogela classe. Wow. It's amazing. It's amazing how you see these things. The diagram look complicated. So someone might not understand what you're talking about, especially if the person is not doing maths. Look at the diagram. It seems too complicated, but you guys, you are figuring these things out. That's impressive. That's so amazing. Oh, so you guys, you are just applying the theorems that are applicable, ne? You are looking at the possible theorems that we can apply. Okay, remember we are not answering the question. We have not yet started answering the question. Let me say, let's look at angle A3. Let's look at angle A3. I'm not disturbing you, Senja. I've realized I was very impressed when I came here. Those things that you were saying, they were very valid, and that's impressive. Angle A3, lenana rilikana which angle? Angle A3. Can you please erase, if it's possible, on your side, Senja? Okay, and I can erase your ink. I need to I erase it. Oh, it's fine. It's kawar. We will just disregard this ones. A3 unana rekalikana le which angle se silebogang? Angle A3. Let me give you the theorem. Angles subtended by the same chord are equal. Unana A3 ikalikana le which angle? I gave you the theorem. You just have to use the theorem. Angle A3 is equal to which angle? Angle subtended by the same chord. Some says angle in the same segment. Some says angles in the same segment. So A3 na which angle? This question paper, this question is so very amazing. I will keep this one. This question is so great because it's already theorem challenge. Leboganga, are you still here? Okay.
Angle S2.
Great. Wow. Amazing. Angle S2. Angles subtended by the same chord or angles in the same segment. You guys, you are very smart. Angle B1. Angle B1 is which angle?
Angle T2.
Amazing. Angle T2. Same reason. Angle in the same segment. Angle B2. You guys, you've already spoke about this one. Angle A2. Same reason. Angle in the same segment. Angle T1 is equals to which angle? Center.
Angle T1 equal to S1.
S1, great. Angle in the same segment. You guys, you are very smart. I've realized that. Let's just explain to the viewers, those who will watch this video later on YouTube, why we say angle A3 is equals to angle S2. We say angle A3 is equals to angle S2 because these angles, they are subtended by the same chord. The chord is BT. Let me check something here. Can you guys mute your speaker? Can you guys mute your speaker? Yeah, thanks. Why is angle A3 is equals to S2? We say these angles, they are subtended by the same chord, namely BT. If you can ask yourself, how is angle A3 formed? Angle A3 is formed by this line, and this other line, both this line comes from B and this line comes from T. So we say angle A3 is subtended by BT. The same with angle S2 is made up of this line and this other line. Where is this line coming from? This line is from B and this line is from T as well. So these angles, they are subtended by the same chord. So they are equal. The same with angle B1 and T2. Angle B1 and T2. The chord here in this case is AS. They're subtended by the same chord AS. If you look at the angle, the lines that form angle B1 is this line and this line. This line comes from A. This line comes from S. So we say B1 is subtended by AS as well as T2. The line comes from A and then the other one comes from S. So subtended by the angles subtended by the same chord are equal. That was very great from Leborang and Sintwe. They really understand these things. Now we are just applying the theorems. Here we apply the theorem which state angles subtended by the same chord are equal, or angle in the same segment are equal. Let's look for another theorem which we can apply on the diagram. Angle SR, angle S3. Angle S3 is equal to which angle, Leborang? Angle S3 is equal to which angle, Leborang? You can unmute your speaker. Leborang, angle S3 is equal to which angle? It's fine. Angle S3 Sentwe, Unano is equal to which angle?
B, next angle of
B1 and plus B2, ne? Okay, we have this cyclic quad, Leborang. Here it's a cyclic quad. Remember we set a shape that has got 4 sides. 1, 2, 3, 4. We said it's a quadrilateral. And when all the points are at the circumference of a circle, we say it's a cyclic quad. Yeah. Guys, if you're not saying something, please mute. You need to get used to muting and unmuting. Muting and unmuting. So we see that ABTS is a cyclic quad. So we will apply the theorem that says exterior angle of a cyclic quad is equal to the opposite interior angle. Here is the exterior angle, S3. S3 is a cyclic quad. So essentially the opposite. Remember, S is opposite to B. So angle S3 is equal to angle B1 plus B2, the whole B here. S3 equals to B1 plus B2. The reason, exterior angle of a cyclic quad equals to the opposite interior angle. Angle T3 plus T4, when I know which angle, angle T3 plus T4. Ki add T3 li T4. When I know which angle?
a whole angle A.
Wow. Wow. Yeah, here you came all out. You wanted to show the examiner who you are. You are right. Elegantly the whole angle A. Again, this is our quadrilateral, is our cyclic quad, and we say angle T3 and T4 is the exterior angle of a cyclic quad. That's impressive. T3 plus T4, it's equals to SA3 plus A2, the whole A. Same reason, exterior angle of a cyclic quad equals to the opposite interior angle, right?
Oh, sir.
Yeah.
Ba re file gore ba re BR is equal to AR. So it means
Varying.
B line BR.
Oh, I see that. Line BR from B to R.
Yeah.
BR, line BR, yes.
It's equal to line AR.
Line AR. Let me use this symbol to indicate that they are equal. Line BR equals to line AR. Okay?
So the opposite equal lines opposite equal lines opposite equal angles or angles of the cyclic quad or of an isosceles triangle.
Yeah, not cyclic quad. When you say isosceles triangle, I'm happy. So which angles are you talking about?
A3 plus A2 and B1 plus B2.
Yeah, you are on fire.
Yeah.
There you are on fire. There you are talking. Okay, you are right. Because let's say this is our triangle ABR. This is our triangle ABR. And we know that on this triangle ABR, the line BR is equals to the line AR. So we say this triangle ABR is isosceles triangle. Why do we say it's an isosceles triangle? Why are you saying it's an isosceles triangle, Simji?
The properties of a isosceles
triangle. Okay.
Yeah, the properties of it says that it has two equal sides and one side that is not equal to those two other sides.
Amazing.
These angles are equal.
Oh, amazing. Yes, it's an isosceles triangle because it has got two sides that are equal. If the triangle has got two sides that are equal, we say that triangle is isosceles triangle. So triangle ABR is isosceles, having two sides that are equal, side BR being equals to side AR. Now, we have to ask ourselves which angle is opposite to those sides. Let's start with side BR. Let's start with side BR, Lebogang. Which angle do you think it's opposite to side BR? The angle which is opposite to side BR. If we've got something like a triangle like this, Lebogang, a triangle A, B, C, we will say the side AB is opposite to angle C. The side AB is opposite to angle C, and the side AC is opposite to angle B, and the side BC is opposite to angle A. So in a triangle, the side has an angle which is opposite to, whereas the side so until opposite to angle A. So uswane side BR is opposite to which angle? Side BR is opposite to which angle?
Angle A2.
Actually, it will be the whole A. Agree A2 and A3, the karaka triangle. A should be A2 and A3. And then the side AR is, side AR is opposite to which angle?
Angle B.
A, B1 and B2. Angle B referring to B1 and B2. Agar? Agar. Gona angle A, which is angle A2 plus angle A3 is equals to angle B1 plus angle B2. What is the reason? Opposite angles of equal sides. Yes, these are the opposite angles of equal sides. In this case, the side BR is side AR. What are the angle getting opposite to those sides? Again, we have got side BR. Which angle is opposite to the side BR? It's angle A. Which angle is opposite to the side AR? It's angle B. It means that angle A and angle B, they are equal. These are the angles which are opposite to equal sides. So those angles must as well be equal. That was very great. That was very great. Identifying that was so cool. Indeed, angle A is equals to angle B. A3 plus A2 equals to B1 plus B2. What else did we miss? What else did we miss? We missed something interesting. We missed something interesting. Okay. Sharp. Yeah.
Arsadia E3 S2 or the substance like PT.
No.
No. Angle P is equal to angle R. They're subtended by chord TA.
Aha, aha, I like this one. Angle P, angle P for now, I can say it's equals to angle R. Yes, they are subtended by the same chord TA, but they are not at the circumference of a circle. The angle is subtended the same chord, so it be at the circumference of the circle. So di at the circumference of a circle. They are not at the same.
Cyclic quad. Or else you prove a cyclic quad before.
Yeah.
Cyclic quad.
Bakano tabar prove or ATRP it's a cyclic quad. For now, ukaseri angle R le angle P dialekan. That one don't do it. Why? Because legally substandileki TA kachepedi gachona. These angles for now they are not at the circumference of a circle. So we can't say angle R ilekana le angle P. Mara, ge re ka khumana angle R ilekana le angle P. Ge di ka no lekana fela, re tlo re gona o ra re ntwe ke cyclic quad. Ge go ka tlhaga gore angle R ilekana le angle P, gona re tlo re na le cyclic quad ye gatang from A, ya gatang go T, ya gata go R, ya gata go P. It's not my ugly circle. We'll look at it. Surely they might say prove that ATRP is a cyclic quad. They might say that in the long run. What else did we miss? Why? Okay, give me a reason. Why is AP equals to AT? I mean TP. Why is AP equals to TP? Why it's AT? The line AP. Why the line AP is equals to the line from T to P? This is one of my favorite theorem. I don't know why I love this one.
They are tangents drawn from the same vertex.
Same point. Hey, you are right. You are right. You are right. You are right. Tangents drawn from the same point are equal. They all tangent di kam ka tsona di tloga mo go P gore ke PT is tangent PT. O pula ba re boditse gore PT ke tangent. Ba re botsa
yeah, what cannot they are subtended by the same angle? Go on.
Let's just say tangent. Let's just say tangent. Let's just say tangent drawn from the same point. Yeah.
Come go subtend the line fella.
Bonya ka gore eng le eng subtendile ke the same angle.
Okay. Victor P is subtendile. Okay, yeah,
Arnor this line, Arnor tangent yarina, tangent ya TP, it will P. Kuri this tangent, they come from the same point P. It will P, well, bonum. It will P, yagata T. Get tangent. Tangent yung it will P. Yagataru A, still tangent. Now regard tangent, they are drawn from the same point. They all come from point P. We say therefore TP is equals to AP. Tangent drawn from the same point are equal. So TP equals to AP. Kiri tangent Tangent out are pointing at E. From all they comes from P, they are equal. Now, level this structure level. Mpedi angle jaulekan. Looking at the triangle ATP. Looking at the triangle ATP. Ona le angle jaulekan sis level. Go level la triangle ATP. Agri le site le kana le. Ke isosceles. Ndo sanjwe tsibe kore. Go kana ba le ma site ma bedi ya go lekana. Ora that is isosceles triangle. Sanjwe be le di angle ja go lekana. Ke di fe di-angle tša go lekana se se Lebogang in this case?
Angle A1 plus angle A2 equals to angle T2 plus angle T3.
True, because TP, angle A is opposite to our side TP, and then angle T is opposite to our side AP. Gape ge maside a lekana, re no ipotšiša re maside awe are opposite to which angles? Re lebelela the opposite angles to those sides. We say those angles that are opposite to this side, they are equal. So in this case, you are right when you say angle A1 plus angle A2 is equals to angle T2 plus angle T3. Now you are writing is a relevant sense. You are writing it's very relevant. It shows angle A1 plus angle A2 being equals to angle T2 plus angle T3. Yeah, I think we have exhausted the theorems here. We have said a lot of theorems. We did not apply tan court. We did not apply tan court, but you guys already applied it. When I came here, you were talking about it, tan court theorem.
Mara ka re dile A1 fela.
Only the relay one.
E1. Yeah, E1 re tlo R side ya.
Okay. Lebogang angle A1 e o lekana leng. Angle A1. You lekana le which angle? This question is very informative. I mean, yeah, this question paper, it was well said. I love this question. There are a lot of theorems. I'm going to put this one on YouTube, guys. Make sure that you visit it regularly. You just to make sure that you get everything right. This question is very interesting. Angle A1, tan court theorem is not the difficult theorem, Lebogang. Angle A1 ile kana leng sense.
B1.
B1 true. Tan court theorem is not a difficult theorem. Why am I saying that? Let's first identify our tangent. This is our tangent. And then we identify our chord AS. We see that angle A1 is the angle between tangent and the chord. Go ka lebella gore angle A1 e dirile ke maline afe. Angle A1 e dirile ke this line and this other line. And go ka lebella the line, the red line, it's my tangent. And this other line here, it's my chord. So it means that angle A1, it's called the angle between tangent and chord. And then the theorem stated that the angle between tangent and chord is equals to angle in the other segment. So what you have to do, to find where angle A1 ilekana le which angle. Agar o tla bo tseba chord ya gago gore o bolela ka which chord? O bolela ka chord AS. Angle A1 is between tangent and the chord AS. What you have to do, you have to subtend this chord. You have to subtend AS. Create an angle create an angle using a line from A. So this is a line from A, and also using a line from S. Remember, we said our coordinates AS. Use AS, you realize that angle B1 is subtended by AS. So we say angle A1 is equals to angle B1. The theorem tan cot. Actually, angle A1 is also equals to T2. I see the end tan cot. Yeah, it's just a matter of subtending the cot. How can subtend the cot AS? A line from A, a line from S, try to create an angle over T2. So we say angle A1 is equals to angle T2, tan cot theorem. Okay, Sentwe?
Oh yeah, ya lenkarabile ge dia ya
A1.
ATS. You're
Oh,
correct. Explain to ke chabela o question angle we can say tse o re gabotse
yeah,
re ya ka gore chord ye gore e create a tangent, angle ya tangent e tlhakana le tangent ke yone ye tlo re botsang gore the angle tseo ke tsona angle A1 ke ntwe be ke chabela
the idea go no berekisha that chord. As long as as long as gore chord ya rena ke efe, the chord yeo e ka re thuša go nyaka angle ya go lekana le A1. So chord ye ke e re iša go B1 ya ba ya re iša le go T2. And beside šetše re tseba gore B1 e lekana le T2 using the theorem that says angles subtended by the same chord are equal. Šetše tseba B1 e lekana le T2. So ge re A1 e lekana le B1, go ra re obviously le A1 swantše e lekane le T2. A ke re B1 le T2 tšona ka tšona šetše di lekana. Go ra re angle tše tharo tše gabotse di a lekana tše. A1 ya go lekana le B1, B1 ye leng gore lekana le T2. These angles ka tše tharo ga tšona di a lekana. Angle T3 o nana re yo lekana le which angle se se lebogang T3. Apply tan chord. Remember, this is your tangent here. And this is your chord. TS is your chord. So go ka lebella angle X ya rena is between tangent and chord, which is angle X. So angle X ya rena ye ke T3. Onana lekana le which angle lebogang? If you get this one, I'm happy. If you get this one right, I'm happy. Angle T3 yo lekana le which angle lebogang? Lebogang? Lebogang, perhaps she's struggling with network. Angle T3 yo lekana le which angle lebogang? O tse re o mutile speaker go ka bolela nka se. Yeah.
Lekana le angle A. Ya lekana le angle A2. Yeah.
Yeah, true. Yo lekana le A2 ye nngwe gape ke efe? T3 yo lekana le A2 ye nngwe gape ke efe? E lekana le ye nngwe gape beside A2, angle T3. ko bona re ka nnete wa ikwešiša ge o figure out this other one again. Yo lekana le efe gape? You are right, angle T3 lekana le A2 ya lekana le efe gape?
Angle B2.
Angle B2 through, angle B2 through. Ntho bohlokwa go tseba chord ya gago. Go tseba the chord, o berekiša chord go nyaka angle ye nngwe. So go ka berekiša the chord TS, o tlo bona chord ye forma angle B2. So we say T3 e lekana le go ra re angle A2 ke X le B2 ke X. A ke re T3 ba re le ke X. And re T3 lekana le A2 ke X. T3 lekana le B2 ke X. Angle tše ka moka ke di X. So now let's answer the question. Give a reason why T3 equals to A2 equals to X. Man, we just did this one right now. What is the reason, Sentry? Why is T3 equals to A2? Why are they all X?
Tan chord.
Tan chord theorem. It's tan chord theorem. True. Now they say prove that AB is parallel to ST. Prove that AB, let me draw the lines that are parallel. I mean, they say I must prove that those lines are parallel. I must prove that the line AB is parallel to the line ST. Okay, I must prove that these lines AB and the line ST are parallel. Okay, to prove this, we have to know something about parallel lines. That's why I'm saying this question is so very amazing. You can use it to prepare for the exam. It's a very good question. What do we know about parallel lines? What do we know about parallel lines, guys?
We know this thing they call a fan.
Okay.
There should be a transversal which makes up alternate angles, corresponding angles, and cointerior angles. So we must look for the angles which can make up a.
Okay, I get you. Gantši ge re na le parallel lines, I get what you are saying. Gantši ge go ena le parallel lines, re a tseba gore alternate angles of parallel lines are equal. Let me say this line BS. What's for now? I can show ya gore AB le TS di parallel. Ke swantše ke di prove gore ka nnete di parallel. Ager? Mara if AB is parallel to TS, ke ge angle B1 e tla be e lekana le S2. Kore ge angle B1 e lekana le S2, go ra gore AB is parallel to ST. If angle B1 is equals to angle S2, what are AB is parallel to S2? Why am I choosing angle B1 and angle S2? I have a feeling that something like this is going to come in the exam room, especially around June. Around June, there is a high chance that this one can come June. Why am I saying if angle B1 is equals to angle S2, AB will be parallel to ST? If angle B1 and angle S2 are equal, you have to look at the angle B1 and angle S2. They alternate, or we call them alternate angles. because they will be forming a Z shape. Go kalibella the shape, yeah, angle B1 and angle S2 is a Z shape. Go kalibella this red color and the green color, the shape that I've just drawn here, it's a Z shape. So angle B1 le angle S2, di tla be e le di alternate angles. And the alternate angles di lekana, go ra gore AB le ST di parallel. Ge B1 le S2 di ka lekana, gore AB le ST di tla be di le parallel, with the idea that B1 and S2 are alternate angles. Or if I realize that, the whole angle A is equals to S free. Once angle A is equals to S free, it means that AB and ST are parallel. Why am I saying when angle A free plus A2? Angle A, I'm referring to A2 plus A3. Why am I saying when angle A2 plus A3 is equals to S3, when these two angles are equal, AB will be parallel to ST? Why am I saying that? I will be considering the idea that angle A2 and A3 and angle S3 will be corresponding angles. So once they are equal, the line AB will be parallel to ST. The angle A2 and A3 and S3, they form an F shape. Shape is an F shape. So corresponding angles. So really angle which seem to be corresponding, AB and ST will be parallel. Again, I doubt this one will be applicable, but I just have to talk about it. I doubt this one will be applicable on this question. If I realize that angle A3 and A2 and angle S1 and S2, if I add this angle, I get 180. AB, it will be parallel to ST, with the idea that these angles are the co-interior angles. Co-interior angles are the angles that form a C shape. You can see this is a C shape. So once A3 and A2 being added with S1 and S2, once this angle add up to 180 degrees, we say therefore our AB is parallel to ST, because angle A3 and 2 and angle S1 and S2 will be the co-interior angle in that case. So let's try to prove that AB indeed is parallel to ST. 5 marks. Woo. Lot of workings. This is what I think is my parallel lines. This is my transversal. So I need to show that B1 equals to S2. Renka khona bontsha B1 le kana le S2. Gona ke tlabe ke bontshitse gore AB is parallel to ST. I need your help here, guys. Is there any way I can show that angle B1 equals to S2? Let's try to show that B1 equals to S2. Let's try to show that B1 equals to S2. Not only B1 equals to S2, or maybe we can show that. Let me do this. Let me not be in a rush. I can also pick my transversal to be A3, ne? Yes. If A3 is equals to T2, it tla be sa le Z shape. A3 tla be alternate le T2. Yes, tla be ke na le the Z shape. Gona go ra gore AB will be parallel to ST. And I'm tempted to use this one, Agbo. I'm tempted to go for this one, Agbo, T3 and H. Because I want before. If A3 le kana le T2, AB will be parallel to ST. My God. If A3 le kana le T2, these things will be parallel. So renale ke dilo tse dintsi tse eleng gore re ka di berekisa. Re ka try go bontsha gore B1 le kana le S2, goba re ka try go bontsha gore A3 e le kana le T2, goba re ka try go bontsha gore angle S3 e le kana le angle A3 plus A2. I'm tempted to start with this one. You need to pay attention here, guys. Renka bontsha gore angle S3 e le kana le angle A2 plus A3. Where AB will be parallel to ST. I'm tempted to try to prove that S3 e le kana le A2 plus A3. Can we try to prove that? Where angle S3 e le kana le A3 plus A2. Is it going to be possible to prove that or angle S3 e le kana le A3 plus A2? Or maybe angle T3 plus T4 e le kana le B1 plus B2. 5 marks.
Returning T3 plus T4.
E le kana le retry gore le kana le B1 plus B2 ager. Yeah, actually re ke mekgwa e mentši re ka e berekisang go prove gore dilo tše di parallel. Wena o bolela ka T3 and T4 re bontshe ge T3 plus T4 e ka lekana le B1 plus B2 gore re AB is parallel to ST. Kore go ka bothata tsa keng aba mo a re tsebe gore rene go ka lebella ke dilo tše dintši tše ka trang o di berekise. So it's going to be tricky in that case. Because o khomana le o thoma ka e leng gore ka se go thushe. For example, o kera o try go prove gore T3 plus T4 e le kana le B1 plus B2 and e sa kgonege. O kera e le gore a one enough information ya go bontsha gore T3 plus T4 e le kana le B1 plus B2. A khomana e le gore tsela o itšereng e ka se go fitlhiše answering. So sometimes it's a trial and error method. You have to work.
So say na personal vampire question to so. Banti ke shumisha engile vampire nyona. Ke tsamaye lono ke nyaka engile tše dingwe jalo ka yona.
Ke a kwishisha gantši o swantše o berekiše the given information. O lebella angle tše di leng gone ke a go agere ye nngwe tse ye nna ke dirang ke efe go lebelela the previous answer or na how can the previous answer influence agere resolve le 10.1 in this case re ka lebelela gore na how can the answer ya 10.1 e re thushe go solve question ya 10.2 wangutshishi because gantši no khumana previous answer is useful in getting the answer potšišo e tlabeng e le on hand. So let's just try all our best. Let's try all our best. Do we know anything about weight A2? A2, it's not part. This 5 marks, Roberek Rishala Rekuman. Aris Kalebala B BR is equals to AR. Erki red color. Information yung weleng tlo ba botlhokwa. A re ska lebala gore angle B1 le B2 e lekana le A2 plus A3, my God. Ooh. Ooh. You see, if you just forget one bit of information, it's out. You won't get the answer. It's clearer now. It's clear. Because, wow, these guys, they are very smart. Mathematicians are very smart when they ask their question. What do we know, Kor? I also see it. Angle S3 is equals to B1 plus B2. What is the reason? Why is angle S3 equals to B1 plus B2?
Exterior angle of
a cyclic quad. Exterior angle of a cyclic quad equals to the opposite interior angle. This one before. Agere cyclic quad yarnashi. Then there are S3 ikan tlaga cyclic quad. Rar exterior ilikanali the opposite interior angle. So S3 ilikanali B1 plus B2. Rabuaga perar. We know that angle B1 plus angle B2 is equals to, can you guys please mute your speaker for a while? Angle B1 plus B2 is equals to angle A2 plus angle A3. What is the reason? Let me go and draw that again so that it can be clear again. Remember that this side equals to this side. Therefore, this angle equals to this angle. So what is the reason? Opposite angles, opposite equal sides. Angles which are opposite to equal side. So angle B1 plus B2, elekanale A2 plus A3. Now, therefore, I can conclude that angle S3 is equals to A2 plus A3. Agar S3 elekanale B1 plus B2, mola B1 plus B2 elekanale A2 plus A3. Ora lechel chona dia lekana chi. S3 elekanale A2 plus A3. Lebaka kore S3 le A2 plus A3 dilekana le ntweti. S3 lekana le B1 plus B2. Mola A2 plus A3 liona lekana le B1 plus B2. So ora S3 le A2 plus A3 dia lekana. And then rile ge ka khumana ile gore angle S3 rile ger ka khumana ile gore angle S3, okay, rile ger ka khumana ile gore angle S3 ele kana le A2 plus A3 gona AB is parallel to ST and can nitishi S3 ele kana le A2 plus A3. Therefore, AB is parallel to ST. This question is not for, it wants you very awake in the exam room. Hoyakana is a bit challenging. Indeed, AB is parallel to ST. Why? I found angle S3 being equals to angle A2 plus A3. So in my mind, these are the corresponding angles. These are the corresponding angles. So once the angles that correspond are equal, It means AB is parallel to ST. Yeah, Sentwe?
Oh, so if I can push about I get S3 is equal to B1 plus B2 again. And there are T3 plus T4 is equal to
Artlogele T3 plus T4 ganyane ne. Agar S3 ile kanal B1 plus B2. S3 ile kanal B1 plus B2 agar. And B1 and B2 dile kanal A2 plus A3. Do you get that? So gora gore le S3 le A2 plus A3 le tsona di a lekana because di lekana le ntwe eti gore ge X e lekana le Y and Y e lekana le Q. Gora gore X le Q le tsona di a lekana because di lekana agar X e lekana le Y and Y e lekana le Q. Gora gore X le Q le tsona di a lekana.
Ke batla gore vaccine ke lebetse gore BR ke R is equal to AR.
Oh, that's why sometimes it's important when we born child so. Because Lena it first. So or to solve this problem once given BR equals to AR. I saw the question is not that complex as I thought. Laborang, are you still here?
Yeah.
Is it making sense? Yeah? It's not making it make a sense.
Yeah, it makes sense.
Oh, make sure we practice this question. Make sure we practice. Level so. Guys, let me just speaker for now. So. Whenever these lines are parallel, these lines are parallel, automatically, these angles, this angle and this angle, they are equal. The alternate angles, they form a Z shape. This parallel line, a transversal, a parallel line. So this angle and this angle, dialekan. Once or this line, maybe let me say it's AB. Once AB is parallel to CD, or this angle and this angle, dialekan. Ne? Or the parallel or the alternate angles dialeka. So when these lines, what are on a transversal? Go ka khumana ile gore angle e ke 20 le angle e ke 20 AB CD. Le ge ba sa go botša gore AB is parallel to CD, you can tell that AB is parallel to CD. King in AB parallel to CD, get these angles that are equal. And the angle they form a Z shape. So re mar angle the alternate angles. So really lekana gore maline a luona are parallel. Once alternate angles are equal, it means the lines are parallel. Once the lines are parallel, it means the angles are alternate angles. They should be equal. Kuri is just kidding. one can say vice versa. Ge line a le parallel, gora di angle di a lekana. Ge di angles di lekana, gora gore ma lines are parallel. I think I tried to be clearer. When the lines are parallel, the angles are equal. The angles are equal. When the angles are equal, the lines are parallel. I tried my best. That was 5 marks. So AB is parallel to ST. That was proven. So gantši go fetša go prove e be mo question paper mo ska lebala ino re o dieso gore ska tla wa lebala. Even this maline a go lekana le wona dieso ska lebala. Okay, prove that T4 equals to A1. Can you guys try to prove that or angle T4, Yates angle T4 is equals to angle A1? Can you try it? 5 marks, you still need to work again. Can you try to prove that or angle A1 is equals to angle T4? Are you guys working on it? Are you trying to prove that angle T4 equals to angle A1? Do all your best. Try leka go bontsha gore angle A1 le T4 di a lekana. O tsweletse mabaka a gore why o re angle A1 le angle T4 di a lekana. Are you guys working on it?
Yeah.
Lebogang, are you trying your best? Are you trying your best? Are you trying to prove where angle A1 is equals to angle T4?
Yes.
Okay, that's good.
ke kry-ile. Se,
Yeah.
ke kry-ile.
Wow. Wow. You got the answer.
Mm, mm.
You think you got it? Like, if you got this one right, ne, I'm putting you on level 7. If
Okay.
you got this one right, you are a level 7 material. So you should strive for that. You should strive for that. If you got this one right, I think you are level 7 material. Wow, that's good. Can you please send the solution on WhatsApp?
Yes, re ke ngwaleng ga botse.
Oh, yeah, ngwale we send. You're still pushing agere Cecile Bogang. You're still fighting again. Since you speaker more fun. Yeah, thanks. Are you winning, Lavogan? Do you think you are getting there?
No.
It's tough. No, don't worry, don't worry. Rome is not built in a single day. Rome was not built in a single day. So don't worry, we will eventually get there. Practice makes perfect. Some say practice makes perfect. Can you send me your work? I just want to see what is it that you were doing. Can you, whatever that you were writing, can you take it a photo and send it on my WhatsApp? Ari Sentwe. Ke emetše solution ya gago ke dire corrections. Ke bona gore na.
Ke sendile.
Oh, we send it. Eish. Beginya go chia ki for ki copy ki paste there. Shio ya ntwenye. Copy paste. Simple thing, just copy and paste. Let's see what you have done. Let's just go through what you have done. You are saying T3 plus T4 equals to B1 plus B2. Corresponding angles, true. You are saying angle T3, I will need to erase a lot of things here. Let me pull this one up. Yeah. Remember, we have proved that AB is parallel to ST. Now we know that AB is parallel to ST because it was proved. Now you are saying angle T3 plus T4 equals to angle B1 plus B2. You are saying these are the corresponding angles. Because it was proved. You are right. You are right. You have a valid point. You have a valid point. T3 plus T4 equals to B1 plus B2. You are right. And then, okay, let's see what you're doing after. Now you are saying X plus T4 equals to B1 plus X. X plus T4 or T3 kanaki X. T3 kanaki X. X plus T4 equals to B1 plus X. X plus T4. Oh, actually, I get T3 plus T4 equals to B1 plus B2. Get the corresponding angles. T3 and T4 correspond to B1 plus B2. T3 or X. It's given.
Oh, bekere gone mo ke shite ka part ya gona ka fase mo le seng ke ithome ka yona pele ke be ya bobedi e be ya boraro.
Oh, ke bona. O nyaka go tlo re tlhalosetsa gore B2 ke X for sure. So to B1 plus X. Actually, o state gore B2 le yona ke X. Why B2 is X? Because we set angle T3 is equals to B2 tan chord. I get angle A3, T3 equals to B2. The angle between tangent and a chord. This is our tangent. This is our chord. So this T3 angle X is between tangent and a chord. So it's equals to T3 equals to B2. T3 equals to B2. And T3 is already X. What are B2 Leonaki X? So okay. Then let me see what you've done after. So you said T4 equals to B1. I think it's algebra here. I think what you are doing is algebra or added like terms. X ye yakaku. So what are T4 equals to B1 plus X minus X. Therefore, T4 equals to B1. Wow. 100% correct. 5 marks. I can never prove it. Unyagar T4 prove relekana le A2. Renar prove le T4 elekana le B1. Again? Prove le T4 elekana le B1. So somehow uswanchu bonche gore le B1 ye. Ka mokgwa o dirang ka gona. Uswanchu bonche gore le B1 ye elekana le A1. O T4 swantse re bontshe re ke A1 ntwe ke T4 le kana le A1. So B1 ye swantse B1 o swantse re bontshe
Okay, what did you go check out?
Oh, we ngwadile.
I'll say feature.
Oh, urile A1 equals to B1. Turn code. A1 equals to B1. Nokia. A1 equals to B1. A1 equals to B1. This is true. Angle between tangent and chord. A1 equals to B1. True. A1 equals to B1. Turn chord. So kaur dilekana le B1 kamuka. Lichwana dialekan. Therefore, we can conclude that T4 equals to A1. Yeah, you are right. Therefore, T4 equals to A1. Wow. Wow. I'm very proud. That's so good. You should strive for level 7. Cecilia, is there any question that you want to ask regarding what we were doing here? We were trying to prove that angle T4 is equals to angle A1. Is there any question?
No. I can a question.
Oh. O kushishitso re tlile jwang go fitlhile jwang gore T4 le kana le A1 again? That's good. That's good. That's good. Let me do this. A kgone gore o ka phumula sentle e sa gane.
Ntho ke o kare a isa ngwala mo lephepeng, e ngwadile mo screen-ing so.
O swantse o erase screen. O swantse o erase o ka mokgwa o ngwadileng ka ona o swantse o press rub.
Ke press erase again.
Erase.
Yona eno dia mara a erase gona.
Oh. Le nna ke kwele go botša nnete akere ke kwele balo mo ke bar prove that RTAP is a cyclic quadrilateral. Šetše ke diagetše no re ko robalaneng. RTAP wa e bona ntse la rileng ba kana tla ba re botšiša gore re prove gore ke a cyclic quadrilateral. It's a cyclic quadrilateral because re šetše re bontšhitše gore A1 e lekana le T4. A1 ke e lekana le T4. So because A1 e lekana le T4, review this thing as a cyclic quad. Re bona quad ya rena in this case re ke RP. So re di substandile ke the same quad RP T4 ye le A1 o gopola di a lekana. So the fact ya gore di a lekana re go na le cyclic quad. Ke tlo explain next time when we meet I will explain this one. But the fact ya gore T4 e lekana le A1, RTAP becomes a cyclic quad. Could you explain next time when we meet? From my side,
2 marks. This question mo e tswella ga botse and ne eno go mbetha ge e tswella o kere go sene gape question e ta ka di-link e tshwere di-link so I'm going to T2 10.2.2 a eo then ba no fitlha ba re RTAP is a cyclic quad proof. 7 marks.
Bar 7 marks. But go tlo ra re wena o swantse ba bontshe gore A1 e lekana le T4. Go ka no ba bontsha re A1 e lekana le T4. Gona tla o ba bontsha re ke cyclic quad. Not only A1 and T4, maybe o ba bontshe gore angle R e lekana le angle P. O tla bo ba bontsha gore ke cyclic quad, because ge o re angle R e lekana le P, in that case quad ya gago tla bo viewa TA
or T1 lekana le P.
100% correct, or T1 e lekana le angle P, because T1 e tla be le the exterior angle. Ke tše dintši or T or wa itiri yona a se yona. A3 ka se be yona, wa kuša re wa e ka se be yona.
Gabotse ka euclidean a šomiše di-vertical opposite angles ga botse a di bereke
ka ge re prover
mo euclidean ke ra gore a zanka tlhakane le vertical taba ya go leka re vertical opposite like
go mo tlo ikereye o no bo senke o ikereya kere
e tla tla ka final
itlotla and itlo a ono riska a seng gore a ono riska tla mara somehow you will meet it in Euclidean geometry. I'm quite sure vertical opposite angles are equal.
Gabotse usually ge ba sa go fa la bona mo line leke mo di intersectang TP le RTA.
TP le RA, yes
ge ba sa go fa mo mane ge ba sa go fa point mo go rera gabotse ga gone taba ya mo mose
ever sa go fa selo gantši like this eno ba tuki it's very rare gore o berekiše information ya mo. It's very rare. It's very rare. Eno tshwana le ya mo, eno tshwana le mo.
Because I was at far point.
Yeah, or lebile ga gona le information o ka reng ya linka that much, but you know mathematicians a o nyaka gore o conclude ka re useful. A re gore useful ge le so it's just the question tše be re di answer a di a tlhoka gore re berekiše vertically opposite angles.
Okay, next time issue the proportionality tše jaaka mo gare ga theory ga euclidean le ka re ga second basis.
Be ke nana re moki question re tla e dira ge re meetane be ke re gane maybe le mo e ka no ba ile applicable mo ya e gona
Yo applicable ke get 90 we get point F
F1 le kana le F3 vertical
the F
positive. Eh.
I can radius the chord base chord one radical into divide and believe an 1988.
Eva F1 ke 90, F2 ke 90, F3 ke 90 ke a kushish.
So come with
Eh,
the F cointeri yes or because F1 ke 90 so what are we parallel
what are OG
G
is parallel to AF. She. Ba go botšiša
okay.
yona. She.
Oh, over Marvar GOAC
AC ke no ba AF. Lega a kry ka seropi. Ge AC ye ke yona AF yona ye is the straight line.
We should extend
O should we extend sure. So the fact ya gore mo ke 90 le mo ke 90 re ntho tše ke di corresponding angle gona gore re the lines are parallel. Why angle DAB ile 90?
D A
B D A B. Why this angle ile 90? This angle
in a semicircle.
angle in the same circle, true. Okay, Asia guys, yeah.
Property check get a 90 or no more. Over as well normally I see as in properties check the kite.
Well, the 90 guys with the properties check kite and the properties check kite le nna ke di leverage. I don't want to lie.
I get is I get about one African while he can while today come as a one
Eh,
the reverse.
oh,
I the right
o checkile
skate on
properties check kite and mo ke bile a di tlhokege gore I doubt gore di a tlhokega gore mo ba nyakang G1 re prove re G1 e lekana le B1. G1 e lekana le B1. I wonder how we prove that angle G1 e lekana le B1. This question seem interesting as well. Angle G1 equals to angle B1. How can we figure out that angle G1 is equals to angle B1?
F angle G1 is equal to angle A2 ne.
Oh, because re tla be re bontšhitše gore di parallel again.
G1 equals to
Angle
A2.
G1 equals to A2 ke di corresponding.
So re
lwele gore A2 e lekane le B1 ager nyako G
but I agree. Oh, the ray F3 is common. Let's just set it common. Or BC is going to B8 or B1 is going to B2 again.
B1 e lekana le B2 ke a kwešiša wa tsa nna mara ke reng ke re A2 e lekana le B1 subtended by the same chord DC.
A2 is going to
B1 angle in the same segment.
Oh, you construct DC. Okay. Simple.
Therefore G1 equals to B1.
Yeah,
9.3.
I want to teach I so. Chile Pamatanya, Chile, Mario, DG.
over GA. Yeah, I could say it challenge.
Yeah, you are challenging cake. Only woman, oh, carry. Young carry very bendy, the super converse or which one?
Hey, okay, one the converse of a theorem. Ntoka idirang whatsapp dirang. Lo ga tlana le tsona o mpoche re sekasek.
Yeah, Eric Romelian something,
Yes, similar.
yeah. You know about drawing, freehand drawing, and at some point, yeah, continuing. Don't jump to like, when you fail on the
Bona sendela question paper sendetseng mo WhatsApp ne. Sendela lebogang. A ke tsebe ke create group ke sendela lebogang. O sa le gona lebogang. O tsamaye. Sharp, beke nyaka sendele yona ke tla try go create a group o msendele mo yona mo group. Sure. Ke lapile monna di tlo go dia diphoso ba tla ba re dia matter jwale re ke no tšhaba monna shiko go khutša. Yeah, but I'm very impressed. You are on fire, especially your Euclidean geometry is sharp. Your Euclidean geometry is sharp. You should do a lot of questions just to make sure that out of 50, you get 45, 49. You actually out of 50 get 50. Why should I leave it?
Why should I leave out that one?
That 5 marks or 1, yeah. You're clearly sharp. You can fight and get to time. Sharp, ne?
Thank you, sir. Thank you, sir.
Sure.